Earthquakes are a normal part of our planet's life. Think of the Earth's surface not as one solid piece, but as a collection of giant puzzle pieces. These are called tectonic plates. They're always moving, but very, very slowly. Usually, they just slide past each other smoothly. But sometimes, the edges of these plates get stuck. The pressure builds up over many years like a tightly wound spring. When the pressure becomes too much, the rock breaks and the plates suddenly slip. This sudden release of energy sends out waves through the ground, causing the shaking we feel as an earthquake. It's a powerful and sudden reminder of the dynamic forces at work just beneath our feet. To understand how big an earthquake is, scientists use something called the moment magnitude scale. You might have heard of the Richter scale, but the moment magnitude scale is more accurate for very large quakes. It's what we call a logarithmic scale. This sounds complicated, but it just means that for each whole number you go up, the ground shaking increases by 10 times. So, a magnitude 6 earthquake shakes 10 times more intensely than a magnitude 5. But the energy released is even more dramatic. A magnitude 6 quake releases about 32 times more energy than a magnitude 5. A magnitude 7 releases about 1,000 times more energy than a magnitude 5. This is why the numbers matter so much. Let's put this into perspective. A magnitude 5 earthquake can cause some damage, like cracking walls and breaking windows. It is certainly frightening if you are nearby. A magnitude 7 event is a major earthquake. It can destroy buildings and cause widespread chaos in a large city. We have seen these happen, and they are terrible disasters. A magnitude 8 is even more powerful, capable of leveling entire towns and changing the landscape. The scale goes up from there, with each number representing a catastrophic leap in destructive power. It's a way of trying to measure the truly awesome forces that our planet can unleash upon us without any warning. So when we talk about the numbers on this scale, we're talking about huge differences in power. The jump from a magnitude 8 to a magnitude 9 is immense, releasing 32 times more stored energy. A magnitude 9 earthquake is a truly planet-altering event. It can cause the entire globe to vibrate and can trigger devastating tsunamis that cross entire oceans. We have experienced these in our recent history, and their effects are devastating. They are among the most powerful natural events that humanity has ever had to face. Understanding this scale is key to grasping just how terrifying a magnitude 10 event would truly be for our world. The largest earthquake ever recorded was the Great Chilean Earthquake in 1960. It measured a massive 9.5 on the moment magnitude scale. This event was colossal. The rupture zone, the area where the fault line slipped, was over 800 kilometers long. The shaking was so violent that it caused immense destruction across Chile. It also triggered a giant tsunami that raced across the Pacific Ocean. It caused deaths and damage as far away as Japan, Hawaii, and the Philippines. The energy released was staggering, equivalent to thousands of nuclear bombs going off at once. This magnitude 9.5 event is our benchmark for the worst-case scenario we have actually witnessed in modern times. Now let's try to imagine a magnitude 10 earthquake. Remember, the scale is logarithmic. This means a magnitude 10 quake would not be just a little bit bigger than the 9.5 in Chile. It would release about 32 times more energy. The ground shaking would not just be 10 times stronger than a magnitude 9, it would be on another level entirely. The shaking would feel less like a vibration, and more like the ground itself was a stormy ocean. The waves in the solid rock would be visible, rising and falling violently. No one on Earth has ever experienced anything like this. It's a force of nature that exists only in theory and in our nightmares. The duration of the shaking would also be terrifying. A typical large earthquake might last for 30 seconds to a minute. The magnitude 9.5 earthquake in Chile lasted for a staggering 10 minutes. For a magnitude 10 event, the shaking could go on for what would feel like an eternity. It might last for 20 minutes, 30 minutes, or even longer. Imagine the world around you being violently torn apart for half an hour without stopping. The sheer psychological terror of this, on top of the physical destruction, is difficult to comprehend. The continuous violent motion would ensure that anything that could fall would fall, and anything that could break would be shattered. Comparing it to the Chilean quake helps, but it still falls short. A magnitude 10 event would be the equivalent of the 1960 earthquake happening across its entire 800-kilometer length, but with 32 times the energy release. The fault that would need to rupture to create such an event would have to be gigantic, far larger than any we know of. It would have to be thousands of kilometers long and incredibly wide. The amount of slip, or how far the two sides of the fault move, would have to be enormous, perhaps over 50 meters. It would be an event that would literally crack the planet's crust on a continental scale, a true geological apocalypse. In the area directly above the rupture, the devastation would be absolute. No man-made structure could possibly survive. Modern earthquake-resistant skyscrapers are designed to withstand a magnitude 8, or perhaps even a 9 if they are very close. But they are engineered to sway and bend, not to be thrown around by ground waves several meters high. Every building, from the smallest house to the tallest skyscraper, would be reduced to a pile of rubble. Bridges, dams, and highways would be annihilated. The very ground would be broken, with huge cracks and fissures opening up. The landscape itself would be permanently and violently rearranged. The human cost in the earthquake zone would be catastrophic. For anyone caught in a city, survival would be almost impossible. The collapse of every building would mean there is nowhere to hide. The infrastructure for life, electricity, water, communication, would be gone in an instant. Even for those in open country, the danger would be extreme. The ground itself would be a death trap, with liquefaction turning solid ground into a soupy liquid. Landslides on an unimaginable scale would sweep down from any hill or mountain, burying entire valleys. The immediate death toll in the affected region would be in the millions, a complete and total loss of life. The secondary effects would be just as deadly, but they would spread globally. A magnitude 10 earthquake, especially if it happened under the ocean, would create a mega tsunami. This would not be like the tsunamis we have seen before. The waves would not just be 10 or 20 meters high, they could be hundreds of meters high. These walls of water would travel across entire oceans at the speed of a jetliner. They would not just flood coastal cities, they would wash them off the map completely, scouring the land clean for miles inland. No coastline on the planet would be safe. The warning time would be hours, but the scale of the required evacuation would be impossible. Furthermore, the incredible energy released could have other geological consequences. The immense stress changes in the Earth's crust could trigger volcanic eruptions around the world. Dormant volcanoes might be shocked back to life. The shaking could destabilize magma chambers, leading to a chain reaction of eruptions. This would fill the atmosphere with ash and sulfur dioxide, which could have a major impact on the global climate. The ash could block out sunlight, leading to a volcanic winter. This would cause global temperatures to drop, leading to widespread crop failure and famine long after the shaking had stopped and the tsunamis had retreated. So we are left with the ultimate question. Is a magnitude 10 earthquake just science fiction? Or could our planet actually produce one? Most geologists and seismologists believe that a magnitude 10 earthquake is, for all practical purposes, impossible. The reason lies in the geology of our planet. To generate an earthquake of this size, you would need a single, uninterrupted fault line that is incredibly long and incredibly deep. We're talking about a rupture that would have to stretch for thousands upon thousands of kilometers, perhaps wrapping a significant way around the planet. There are simply no known faults on Earth that are that large. The Earth's crust is broken up into many plates, not just one or two giant ones. The longest fault zones we know of, like the one that caused the 9.5 Chilean earthquake or the 9.2 Sumatran earthquake, are huge, but they are not long enough to build up the necessary energy for a magnitude 10. For a fault to slip, it needs to be under immense stress, but a fault thousands of kilometers long would likely have weaker points along its length. These would rupture at a lower stress level, triggering a smaller, though still massive, magnitude 9 or 9.5 quake, releasing the pressure before it could ever build to the level needed for a 10. So, while it makes for a terrifying thought experiment, the physics of our planet seem to protect us from such an extreme event. A magnitude 10 earthquake would require a single, continuous rupture zone longer than the entire west coast of North and South America combined. The tectonic plate system just is not set up that way. The plates are segmented, and the faults are not perfectly straight or uniform. This fragmentation acts as a natural safety valve, preventing the accumulation of the godlike levels of energy that would be required to cause a disaster of this magnitude. Our planet is powerful, but there appear to be limits to its fury. In conclusion, a magnitude 10 earthquake remains firmly in the realm of speculation. It is a useful concept for understanding the sheer power of the logarithmic scale we use to measure these events. It helps us appreciate the destructive force of the magnitude 8 and 9 earthquakes that do happen. But based on everything we know about plate tectonics and the structure of the Earth's crust, we can say with a high degree of confidence that we will never face a magnitude 10 event. The ground beneath our feet is restless and dangerous, but it is unlikely to ever unleash a catastrophe of that ultimate world-ending scale.